Hello everyone, my name is Tan Ka Kun from SCCR 1213 Section 9 of Network Communications. This video is the presentation video of my lab 2. My lecturer is Dr. Ahmad Faris Ali. This video contains the demo part of the Wireshark and a report that I have done before in a Word file. In this lab, we will explore several aspects of the HTTP protocol, which is the basic GET response interaction, HTTP message formats, retrieving large HTML files, retrieving HTML files with embedded objects, and HTTP authentication and security. So let's begin our exploration of HTTP by downloading a very simple HTML file. First, we start our browser, which is Firefox, and we clear the recent history. Now we start the Wireshark packet and begin to catch up. And then we enter the link below this to the browser that we open. After open the page, we stop the Wireshark from being captured. And then we enter the HTTP as a filter. That's the demo part of the Wireshark for the part 1, which is the basic HTTP GET response interaction. Now let's go to the report. For the first part is the basic HTTP GET response interaction. For question 1, is your browser running HTTP version 1.0 or 1.1? So from the screenshot below, we can see that my browser is running the HTTP 1.1 version. So let's go to Wireshark. In Wireshark, this column also shows that my browser is running the HTTP 1.1 version. Next is question 2. What language does the browser indicate that it can accept to the server? So from the screenshot, here we can see that my browser can accept the US English language. In the Wireshark, we can find the language from the Wireshark, we can find the accept language here, which is the US English. So next is question 3. What is the IP address of your computer? So from the screenshot, this column shows that my IP address is 192.168.1.3. So from the Wireshark, we can also see that in this column, my IP address is 192.168.1.3. So next is question 4. What is the status code returned from the server to your browser? So from the screenshot, after the GET request sent, our browser received a response which is HTTP/1.1 200 OK. In this column, it's also shown that our browser accepts the response which is 200 OK. So for question 5, when was the HTML files that you are retrieving last modified at the server? From the screenshot, we can see that before that, we enter the HTTP last modified as a filter, so we can see that when is the last modified date. In this column, it shows that my last modified date is on Monday, which is 30 November 2020. So from the Wireshark, we also enter the same thing. And then we can see that in this column, Wireshark shows that my last modified date is at Saturday, which is 5 December 2020. So next is question 6. How many bytes of the content are being returned to a browser? In the screenshot below, we can see that the content line shows how many bytes of content are being returned to my browser. So my browser already returned 128 bytes. In this, we change the filter to HTTP. And from this, we can see that this column also shows that our browser returned 128 bytes. Next is the last question for first part, which is by inspecting the raw data in the packet content window, do you see any headers within the data that are not displayed in the packet listing window? So from my browser, the answer is no. The raw data appears to match exactly with what is shown in the packet listing window. As we can see, the website shows, congratulations, you have downloaded the file with this IP address, with this website. So let's go to Wireshark. Here, the Wireshark also shows the same thing. Now let's go to the second part. Second part is the HTTP conditional GET response interaction. So before performing the steps below, we need to make sure that our browser cache is empty. So we go to our browser and we clear our recent history. After that, we need to start our Wireshark and enter the link below. And then we quickly enter the same URL into our browser again. So let's start our Wireshark. And then we go to our browser and enter this website. And then we just need to click the refresh button. After that, stop our Wireshark. That's the demo for the second part of the Wireshark. So now let's go to the report for the question 8, which is inspect the contents of the first HTTP GET request from browser to the server. Do you see an if modified since line in the HTTP GET? In Wireshark, we cannot see there's any if modified since shown here. So for question 9, is inspect the content of the server response. Did the server explicitly return the contents of the file? How can you tell? So from this screenshot, the answer is yes. We can see that the line base text data shown the content of the URL. So in this URL, this website shows congratulations again. Now you have downloaded the file lab2 to HTML. This file's last modification data will not change, and other things. So in this screenshot below, in the line-based text data also show the same thing that the URL show us. So we can see that from the Wireshark. We can click the line-based text data here, and this shows the content of the URL that we enter to the Firefox. Next is question 10. Now inspect the contents of the second HTTP GET request from a browser to the server. Do you see an if modified since line in the HTTP GET? If so, what information follows the if modified since header? So from here, from the screenshot, you can see that there's a if modified since information state here, which is at Tuesday 1 December 2020. So our answer is it will show if modified since and state a date. So now in the workshop, let's point to the second GET request. Now we can see there's a column which is if modified since Saturday 5 December 2020 stated here. Next is question 11. What is the HTTP status code and phrase returned from the server in response to this second HTTP GET? Did the server explicitly return the contents of the file? Our answer is the server response http:/1.1.304 not modified. The length is much shorter than the full response packet. Let's see the screenshot. This column shows the response of the second GET request, which is http:/1.1.304 not modified. We can see that the length of the response for the second GET request is only 293 compared to the full response packet, which is 432. In Wireshark, we can see that our second response is also 293. It's much shorter than the full response, which is 432. Next is the third part of the lab 2, which is retrieving long documents. In our example thus far, the documents retrieved have been simple and short HTML. So now we will download a long HTML files. The things we need to do is to start our browser again and clear the history. And then start the Wireshark again. Now enter the link to our Wireshark. Then stop to capture. That's the only demo part for the Wireshark. So now let's go to the report. For question 12, is how many HTTP GET request message did your browser send? Which packet number in the trace contains the GET message for the bills? Alright, so from the screenshot, we can only see one GET request to the link that we entered to the Wireshark, to the Firefox. Now for the Wireshark, we can see that there's two GET requests being sent to the link that we enter in the Firefox. Now let's get to the 13th question. Which packet number in the trace contains the status code and phrase associated with the response to the HTTP GET request? So for the response, which show 200 OK. We see that the status code and phase is the packet number is 46. So in the workshop, this shows that our response is 835. Now we go to the question 14. What's the status code and phase in the response? So for the response, we can see from the screenshot here, show that the response is http:/1.1 200 OK. In our workshop, in this column also show the same thing, which is http:/1.1 200 OK. Next is question 15. How many data containing TCP segments were needed to carry the single HTTP response and the text of the Bill of Rights? So from the screenshot, there's 4 TCP segments shown here. Now let's go to our workshop. And we can see here there's a column which is 4 reassembled TCP segments. We click it, and in this column show there's 4 TCP segments. Next is the fourth part of Lab 2, which is HTML documents with embedded objects. Now that we have seen how Wireshark displays the capture packet traffic for large HTML files, we can look at what happens when your browser downloads a file with embedded object. So now we need to start our browser again and clear our history. And then we go to Wireshark and start to capture. Then we enter the link to the Firefox. Then stop capture. Sorry, let's repeat the step again. We clear our recent history. We stop to capture the Wireshark. And then we enter the link. Then we stop to capture. We can see that there's 2 images here, which is Pearson and the appearance of the edition book. And there's words which show this little HTML file is being served by gaia.cs.umass.edu. It contains 2 embedded images, which is Pearson and the 5th edition book cover. Now let's go to the report. For question 16, how many HTTP GET request message did your browser send? To which internet address were the GET request sent? So from the screenshot, we can see that there's 3 GET requests that are being sent by our browser. And the IP address is the same, which is 128.119.245.12. In our workshop, there is also 3 GET requests, which is shown here. We ignore the GET favicon.ico. The IP address of the GET request sent is also the same, which is 128.119.245.12. Next is question 17. Can you tell whether your browser downloaded the 2 images serially or whether they were downloaded from the 2 websites in parallel? Explain. So now we can see from the screenshot. For the first GET request, the source port is 57982. The second GET request have source port 57981. And the third GET request has 57985. So based on the screenshot below, it appears that the image was downloaded serially. Also, the source port is incrementing each time from 57981 to 57982 and to 57985, which means that the image will receive serially over a separate TCP connection. Now let's go to the Wireshark. We click the Transmission Control Protocol. And for the first GET request, it shows 50609. For the second one is 50610. And the third one is 50613. The source port is also incrementing from time to time. So we can see that the image were downloaded serially. Next is the last part of our lab, which is HTTP authentication. So finally, let's try visiting a website that is password protected and examine the sequence of HTTP message exchange for such a site. So now we need to clear our history of our browser again. And then we start to capture. Now let's enter the link to Firefox. This will show a column, page that needs us to enter our username and our password. So for this part, our username is Wireshark students and our password is network. Now let's enter it. Now we managed to enter the website, and the website shows this page is password protected. If you are seeing this, you have downloaded the page correctly. Congratulations. Now let's stop capturing. That's the last demo part of Wireshark for this lab 2. Now let's go to the report. For question 18, what is the server's response in response to the initial HTTP GET message from web browser? For the screenshot, you can see that the server's response is HTTP/1.1/401 unauthorized. This is because we don't enter the password and our username yet. In the Wireshark, we can also see the same response shown here, which is HTTP/1.1/401 unauthorized. Now let's go to the last question of this lab, which is when your browser sends the HTTP GET message for the second time, what new field is included in the HTTP GET message? We need to point to the second GET request, and there's a new field shown here, which is the authorization field. So now let's go to Wireshark and point to the second GET request. Now we can see here, there's a new field shown here, which is the authorization field. That's all for the report. Next part is reflection. Wireshark is a packet sniffer and analysis tool. It captures network traffic on the local network and stores that data for offline and analysis. After conducting this lab exercise, I have a deeper understanding on how the Wireshark works to capture the network traffic and how can the user read the data of the network by using Wireshark. I believe that this experience and knowledge will help me a lot in the future, both on study and when I go to work. Apart from that, this lab also allows me to know better on how the network works to deliver and accept signal or information, and how can the information display. Since this is an individual work, I conduct the lab alone with little help from my friend when I face any problem, such as where is the information of the Wireshark located. I really appreciate the help I received from my friend and my lecturer, Dr. Ahmad Faris Ali. I'm happy that this lab can be conducted successfully and managed to teach me some useful knowledge. That's all of this video. Thank you.